Have you ever marveled at the intricate details and smooth finishes of metal parts used in machines, automobiles, or even smartphones? Achieving such precision requires advanced manufacturing techniques, and at the heart of it lies computer numerical control, or CNC machining. This process relies on meticulously crafted programs that dictate the movement of cutting tools, shaping raw materials into precise components. CNC machining has revolutionized the manufacturing industry, enabling the creation of complex parts with incredible accuracy and repeatability. From aerospace components to medical implants, the applications of CNC machining are vast and continue to expand. At the core of this transformative technology lies CNC programming. For aspiring and seasoned mechanical engineers alike, mastering CNC programming is no longer optional, but essential. This skill set empowers engineers to translate their designs into reality, bridging the gap between concept and creation. By understanding the language of CNC machines, engineers gain unparalleled control over the manufacturing process, ensuring that parts are produced according to exact specifications. The ability to write effective CNC programs opens doors to innovation, enabling engineers to push the boundaries of design and manufacturing. It allows for the creation of complex geometries and intricate features that would be impossible to achieve through manual machining methods. Moreover, CNC programming facilitates automation, increasing production efficiency, and reducing the likelihood of human error. Before delving into the intricacies of CNC programming, it is crucial to grasp the fundamental components of a CNC system. At its core, a CNC machine comprises three primary elements: the controller, the machine tool, and the workpiece. The controller acts as the brain of the operation, interpreting the program instructions and relaying commands to the machine tool. The machine tool, often a milling machine, lathe, or router, is responsible for the physical cutting and shaping of the workpiece. The workpiece is the raw material, typically metal, plastic, or wood, that is transformed into the desired part. Understanding the interplay between these components is paramount to comprehending the principles of CNC programming. Section 4. Navigating the world of G-codes and M-codes. The language of CNC programming revolves around G-codes and M-codes, which provide specific instructions to the CNC machine. G-codes, short for preparatory codes, govern the movement of the cutting tool. They dictate the path, speed, and coordination of the axes, enabling the machine to execute precise cuts and movements. M-codes, on the other hand, are miscellaneous codes that control machine functions beyond tool movement. These codes manage actions such as turning the spindle on or off, changing tools, and coolant control. Together, G-codes and M-codes form the backbone of CNC programs, providing a comprehensive set of instructions for the machine to follow. Section 5. A practical example. Deciphering a CNC program. To illustrate the practical application of CNC programming, let's examine a simple example. Imagine we want to create a rectangular pocket on a block of aluminum. The CNC program for this operation might look like this: N10G00X0Y0Z0, rapid traverse to home position, N20M06T1, tool change to tool number 1, N30M03S1000, spindle start clockwise at 1000 RPM. N40G00X10Y10, rapid traverse to starting point, N50G01Z5F50, linear interpolation to depth of 5 mm at a feed rate of 50 mm per minute, N60G01X30, linear interpolation to X30, N70G01Y20, linear interpolation to Y20, N80G01X10, linear interpolation to X10, N90G01Y10, linear interpolation to Y10, N100G00Z0, rapid traverse to Z0, N110M05, spindle stop, N120M30, program end. Each line of code represents a specific instruction for the CNC machine. For instance, N10G00X0Y0Z0 instructs the machine to move to the home position X0Y0Z0 at a rapid traverse rate. Similarly, N50G01Z5F50 commands a linear interpolation to a depth of 5 mm at a feed rate of 50 mm per minute. Section 6. Conclusion. Embracing the power of CNC programming. CNC programming is an indispensable skill for mechanical engineers, empowering them to transform designs into tangible realities. By understanding the fundamentals of CNC systems, mastering the language of G codes and M codes, and deciphering CNC programs, engineers gain unparalleled control over the manufacturing process. As you embark on your CNC programming journey, remember that practice is paramount. Experiment with different codes, simulate programs, and don't be afraid to make mistakes. Embrace the power of CNC programming and unlock a world of manufacturing possibilities.